Hello, everybody. Thank you for joining us today. On behalf of the Mass Save sponsoring utilities and energy service providers, I'd like to welcome you to the heat pump buying guide. Today we'll be talking about heat pumps. If it's not apparent in the name, right? Focusing on a couple of quick things: engaging with contractors, getting high quality contracts and proposals that meet your goals, and beyond that, um, when you're ready to make a decision, ready to adopt heat pumps, that you're well equipped to make the best decision possible for your specific home situation. So let's get started today. This presentation is provided to Mass customers, sponsored by utilities and energy service providers that make up Mass Any questions about the program and any services that are offered through Mass we recommend that you check out masssave.com, because there are a lot of great resources and incentives that will help you reduce your energy consumption, improve your comfort, and save a little bit of money along the way. And that's just beyond heat pumps. There are a lot of really great programs that you can tap into, and masssave.com is a good place to start. So let's dive in. Um, like I mentioned at the beginning, we will be talking about kind of three main things: working with contractors, comparing heat pump quotes, helping you to make an informed decision. And this is going to be um, assisted by a quote comparison tool that we'll talk about a little bit later on, and then maximizing incentives from the sponsors of Mass Save. Many incentives that are open and available to you. So we won't go into any too technical of information, as since you're here, you're most likely understanding of and know of the benefits that accompany heat pumps. But we will do a quick overview and dive into the technology just a little bit. So what are heat pumps, right? Uh, in the recent years, heat pumps have gained a lot of recognition as a highly efficient electric alternative to your home's heating and cooling needs. Um, I think it's always helpful to put this efficiency into context, something that we're kind of all familiar with, and grounds the discussion, at least, right? So when we're thinking about boilers and furnaces, most modern boilers are over 90% efficient. That means that for every 1 unit of power consumed, they'll produce just under 1 unit of heating power. It's not one for one. They're losing a little bit of energy in some form, right? Um, and then furnaces fall in the range of 85 to 95% efficient. So again, they're losing energy. It's not a one for one kind of exchange there. Heat pumps are different. And this is kind of the wonder of heat pumps, the high efficiency nature. Two of the most popular models from different manufacturers are 410 and 610% efficient at 47 degrees Fahrenheit, which is a rated temperature. That's a huge difference, right? 410 and 610 compared to 85 to 95% efficiency. You can imagine how both the environmental benefits and then the cost savings are just inherent in that efficiency there, right? That's a huge difference. Now, heat pumps don't always maintain such high COPs, but they are always above one. They're just more efficient. Um, Heat pumps are not burning traditional fossil fuels in your home, so there's no byproduct. And they are actually well equipped to capture airborne contaminants, including dust, smoke, et cetera. Right? The list kind of goes on there, and it all speaks to improving indoor air quality for you and your home, right? Typically, when we talk about heat pumps, we talk about how comfort in a temperature sense will improve, but also in theory, right? So is the air you're breathing, right? In increasing the comfort kind of holistically there. The next point, they can be less expensive than traditional fossil fuel systems, especially oil and propane, and can be on par with natural gas or slightly above, slightly below, depending on the application or depending on the rates. Homeowners who install air source heat pumps also get cooling, right? So it's both a heating and cooling system, and you can expect to save about 30 to 50% on cooling costs as compared to a standard central air conditioning system. So that's that typical AC unit that we see outside of a home, and that's typically ducted in our New England homes. And then finally, when paired with a clean power supply, the environmental benefits are even greater, right? And the good thing about being in New England, particularly Massachusetts, is we already have a pretty green grid, which I mean is powered by renewable energy, right? And this helps us maximize the environmental benefits of heat pumps. So the heat pump buying process, right? It's important that as we go through this, we are thinking about getting multiple quotes, and this is going to be a theme throughout the entire presentation today, and something we're hoping you kind of take with you as you start to really consider adopting heat pumps, and as you start to go through this process here, right? Whenever we are consulting with residents, we're recommending that customers get multiple quotes and are doing so both with manufacturers that represent multiple brands, um, and again, manufacturers that represent kind of a wide array in different tech technologies or different systems that are available in the marketplace. And we're recommending this to ensure you are getting a look into what the best possible system and configuration is for your home, right? So once you have done your due diligence, once you've gone out in the marketplace, requested some proposals, received some proposals, you can run a quote comparison report. And this evaluation, it comes at you no cost through the sponsors of Mass Save. And it is designed to really help you understand the difference between the quotes that you have received, highlighting important information such as cost effectiveness, impact on heating and cooling, environmental benefits, a good number of data points, and actually a few other data points that we'll go into in a little bit later in the presentation. So after we have done our due diligence, once we have completed and received that quote comparison report, it's time to select an installer, and it's time to complete that eligible installation, right? And we want to make sure that when we are completing the installation, we are going with a home performance installer network contractor, so an HPIN contractor. Um, and these HPIN contractors can be found on the Mass Save website. And you can feel pretty confident that they are familiar with the rebate process, familiar with the eligible equipment and qualifying equipment. Um, and then once all that has happened, then you can claim your Mass Save rebate for eligible systems, right? And we'll actually, again, later on in the presentation, go into how much money in rebates and incentives you have access to as a Mass Save customer. So the heat pump installer network, right? We in the Mass Save program, you are required to work with a 8-pin contractor. And this can be accessed on the Mass Save website, right? Where you can select one of these improved installers and ensure, like I said, that your installer knows and understands the rebate process and can also represent the program's goals at the end of the day. And I think that's one of the more important parts of this all is that these contractors know kind of the energy efficiency aim of the program and are working with you to get the best solution for your home, right? So only HPIN contractors can offer Mass Save incentives. So it's important that you are utilizing that list as both a requirement, but also a resource in which you are finding installers in your area that will help your switch to heat pumps. So we're gonna dive into some common considerations here. And you'll see the list in front of you, and I'll try to go into a little bit of depth, right? Um, because we are all approaching this adoption from different areas or different perspectives with different motivation and goals. Um, so when you are thinking about getting heat pumps, there is a lot to consider. What's driving you to consider installing heat pumps instead of installing a traditional fossil fuel system or even doing nothing at all, right? Being able to determine your motivation will allow your installers to better select a piece of equipment that's meeting your true needs, right? So whether it be improving comfort, whether it be kind of improving cost efficiency, whether you are approaching this with an environmental mindset, right, and improving environmental outcomes for your home, for the Massachusetts, and for the environment as a whole. Um, but again, it speaks to the fact that people are coming from different perspectives, from different areas. Um, and I want to emphasize that heat pumps are not just heating solutions, right? They will effectively and efficiently meet both heating and cooling needs. I think that's an important thing to reiterate through our entire conversation here, right? And particularly in New England, the fear is that maybe heat pumps can't go down to that low temperatures that we experience in winter, right? Even negative temperatures. But the equipment on the market today is well equipped and prepared to be able to meet your heating needs down to very, very low temperatures and also satisfy those cooling needs to high temperatures as well. So the next one, will your heat pump be the primary heating source, right? It doesn't have to be an either or. One of the goals of Mass Save is to displace as much traditional fossil fuel heating as possible with heat pumps. Like I said, there is equipment on the marketplace that is highly effective in cold climate. So it's actually going to, right, your current boiler, your current furnace, uh, match the kind of comfort that you feel in low temperatures with this electric solution, right? Because these equipments are rated specifically for the cold climate, specifically New England's cold climates. And we actually are in a place where we have years of successful whole home installations where we can point to that show in our examples of these systems meeting needs at both the high and low temperature ends of the spectrum there, right? We'll talk about this a little bit more later on, but there are different routes whether you want to pursue either a kind of a primary heating source or a whole home solution, or just a partial home solution, right? That's going to supplement some of your heating and cooling needs, or offset some of your current heating and cooling which is done by a boiler or a furnace or traditional kind of fossil fuel based system there. Another consideration, and this is a recommendation we always like to start with, right, is recommending that we take advantage of Mass Save home energy assessment, right? Mass Save does offer no cost comprehensive energy assessments to all residential customers. As part of the assessment, an advisor, a professional energy advisor, will conduct a thorough analysis of your home's energy use, right? Offering tips on appliance usage and providing a report that details recommendations and estimated savings for most suggested improvements. And through Mass Save, right, paired with this no cost home energy assessment, you can um, receive incentives that cover the complete cost of air sealing, but also up to 75 or 100% of insulation, depending on your income level or size of the building. Um, so Mass Save is built in a way in which residents can take advantage of it to really improve the comfort of your home, improve the efficiency of the heat pumps, right? If we install weatherization and pair that with a heat pumps, we're tightening up that home and making it more efficient so that the system can actually be smaller, right? If we're tightening up the home's heating load is less than what it was before. So we can actually explore a system that might be smaller, that might not require as large of a upfront cost. So it's always a good idea to start with a Mass Save home energy assessment just to kind of get a feel for where your home is at and what improvements can be made at a pretty low cost. And cost, right? That brings up the next question of how to pay for heat pumps. The sponsors of Mass Save recognize that it's not just about the rebates. It's also about the long-term support. So Mass Save 0% interest heat loan is a great tool to help you tap into, like I said, a 0% loan over 7 years, up to either 25 or $50,000, depending on the project. So this could be a really great way um, as you are financially planning of what makes sense and how heat pumps might work within your home and how you can pay for it. The heat loan is something that a lot of residents have chosen to explore and chosen to go with. as it is a great financing option. The last consideration, right? What is your pre-existing heating fuel type? And this does make a difference, right? Um, and I believe this is the real value of working with a quote comparison tool and then a optional follow-up consultation, is that there's no agenda being pushed. We're meeting customers and residents where they are at, right? If a customer has a high efficiency natural gas furnace, then there are additional considerations to cost savings, whether you have an oil or propane based system, right? The solutions that are being offered and discussed will be prioritizing your needs, your motivations, your goals, and it's not just a kind of full-fledged effort to adopt heat pumps. It's to adopt heat pumps that make sense in your home's context, in your life's context as well. I think that's important to kind of remember because these are big decisions that we're making with both financial comfort, environmental impacts, so we want to be making sure that customers feel comfortable with that decision, um, and are doing it with the kind of most accurate and most in-depth information possible. So next up, we are going to be talking about the two specific kind of types of heat pumps, right? The first one is going to be ductless, right? So that is not utilizing ducts throughout the home. And then the second one is ducted heat pumps, right? And I always like to just start off with some quick background here. That an air source heat pump system uses electricity to power a compressor that transfers heat using the same idea behind refrigerators. That's the common um, kind of analogy that we use, right? You can think of a heat pump as just a either typical refrigerator, or a refrigerator working in reverse, right? In winter, it transfers heat indoors. In summer, it transfers heat outdoors. So you can again think of it as a refrigerator and air conditioner that can also work in reverse there. Typically, you'll see an outdoor condenser that looks something like either a central AC unit or kind of a rectangular box on stilts, we like to call it there. Um, right? And that's either connected to an air handler, typically located in either an attic or a basement, or it can be connected to what are called mini splits, right? And that's what we are seeing on the left-hand side of this slide is one of those like typical rectangular white boxes. Uh, Today, we actually have access to even a broader range of different options for inside your home. So, right, the wall hung unit is assuming what most people think of when we think of the indoor part of a heat pump. Um, but there are a diversity of options, right? In that middle, that is a floor mount, right? This can be easily installed. It kind of looks a little bit like a radiator, right? At least in where it would sit. And these are becoming increasingly popular and are a great alternative to those wall hung units. Um, Additionally, that third option on the slide here is a ceiling cassette, which can be mounted straight into your ceiling, right? Um, this is a bit of a newer product that does a better job. In the past, there were some complications of actually fitting between joists in the ceiling. And there was an issue, right, of where we could actually install this equipment. But newer models um, are have been designed to better fit within a typical home, right? And I think that specifically highlights that these new technologies are um, are being rolled out at a good pace and are being rolled out with customers' kind of real life application in mind. Um, I actually saw a picture of an installed. It's a picture frame wall unit, so it's exactly what it sounds like. It's a picture frame. It has a picture in it, but it's actually blowing warm and cold air out of the bottom of it. So it's acting like a wall hung unit with the fun design of a picture frame above it. So those are ductless options for inside your home. And right, these are again going to be connected to an outdoor unit, a condenser, either that AC or that box on stilts. But the second option, and you can actually, this picture on the right-hand side does a good job of highlighting the condenser being attached to a either compact or centrally ducted uh, unit indoors, right? And this is where we're talking about an air handler that's typically located in either a basement or an attic. In this application, we see it from a kind of an overhead view, so we can assume it's either in the ceiling or an attic there, right? And we get this question a lot. What if I have or had a central AC, right? How would a heat pump, how can a heat pump utilize my existing ducts? Right, these systems can distribute hot or cold air using your existing ductwork. Um, there are considerations that go into that decision, right? You want to test your ducts, you want to seal them if necessary to prevent leakage and to maintain that high efficiency nature of a heat pump. But today's contractors, and especially contractors on the HPIN list, are absolutely able to discuss your unique home characteristics and again meet you where you're at. So again, we're seeing two ducted types on our screen right here. On the left is a compact ducted, and on the right is a centrally ducted heat pump. Compact ducted usually is more zonal based, right? Where we have them satisfying the heating and cooling needs of maybe one floor or a wing of the house. This typically uses a smaller air handler, which usually serves, we like to say, probably 2 to 4 rooms. Whereas that centrally ducted alternative on the right side of your screen there, that is going to be able to distribute heat and cool air through ductwork connected to vents throughout the entirety of the house or at least a much larger area, right? So that left-hand side, that is again zonal based, whereas that centrally ducted heat pump can satisfy a large space, and both have their benefits. Both should be considered as you are kind of exploring heat pumps as an alternative for your home's heating and cooling systems. But that's just kind of a quick dive into the technology of some of the systems or some of the system configurations that you will be seeing as you start to work with contractors and installers to figure out the solution that best fits your home, right? And two things before we move on that I think are important just to talk about quickly, right? So I mentioned this at the beginning of the presentation, but this is a common misconception, or at least a myth that's kind of um, stuck with us from the older days of heat pumps when they were a new technology, still being tested, still being um, perfected, let's call it, right? Um, so in cold climates like Massachusetts, efficiency cold climate air source heat pumps can provide 100% of a home's heating and cooling needs, right? We can be clear about that and dispel any myths there. Um, so they not only can kind of go down to very low temperatures, but they can also satisfy the kind of whole home's heating load. And they can do so without having a backup heating source to rely upon. And we are always of the opinion that redundancy is okay, right? If you do want to go with a partial home solution and have both a heat pump and then kind of a backup traditional fossil fuel system, that's okay. Um, But we always make sure to emphasize that the heat pumps on the marketplace today are able to satisfy your home's heating needs at very low temperatures, right? Um, so I think that's a good important point to make, and to make sure that they can satisfy your home's heating loads to low temperatures, we always recommend that customers request a manual J or load calculation when you're working with an installer, right? A manual J or load calculation is how HVAC companies measure your home's heating and cooling loads and determine what size system is right for a home, right? In these softwares, right? Contractors, installers will input values on your walls, your basement, your attics, floors, the size of the insulation, how much insulation you have, the size of the rooms. There's a lot of variables that affect how a system will perform. Um, and being able to get a comprehensive picture of your home and all of these different variables will ensure your long-term comfort and will ensure a well-designed and well-performing system. So it's key that as we're working with installers, we're advocating for kind of the best picture of your home possible so that we are sizing and selecting equipment that does work for your home. So this brings us, I think, pretty well to the quote comparison report, right? And this is a tool that is designed to help you select the best equipment possible for your home, right? And we'll do a quick overview and then look into a little bit more depth. Um, but again, here is the value of the quote comparison tool. We again are recommending folks get multiple quotes with different brands and different manufacturers represented. Um, and because there are really good equipment with the major manufacturers, some options may look similar. You may also have a variety, a diversity of options in front of you. And sometimes it can be tough to kind of parse through some of the technical language and jargon and figure out what the quotes are actually telling you and how these quotes will actually um, uh, work in your home. So again, right, not sure if anyone has received quotes recently, but the amount of information varies widely. Some proposals have tons of technical information, but some are very high level, right? And through your Community First partnership, sponsored by the sponsors of Mass Save, you will be able to tap into the quote comparison report at no cost, where we will be able to analyze key questions that come up. Um, right? Whether it be how will this system affect my heating and cooling needs? What is the kind of long-term cost, or what can I expect? What are the cost savings over a long term? It just gives you a better and more informed, um, better and more accurate view to make an informed decision when that time is right. So diving into a few kind of um, let's spotlighting a few different features of the report, right? One of the big things people ask about is cost, and appropriately so. When we are receiving proposals, we actually see on average a delta of about $8,000 from the highest to the lowest quote price, right? And you can see here, there's actually almost like a 9,000 uh, dollar delta from the high to low. Actually, even more. $9,000 right there, right? So it's a great example of the diversity of quotes and proposals that you will be getting. Um, what the quote comparison report does is use the 5-degree temperature mark, and we'll actually do an analysis where we take the cost and normalize it at a cost per ton at 5 degrees. And this is a cost per ton is a typical measure used in this space, right, to figure out how much capacity a system has, how much air it is able to blow out. So recognizing that the variations can be daunting, you want to be able to like ask yourself, what am I really getting for my money? And this cost per ton at 5 degrees shows that system performance at the low temperature, so you can kind of figure out which systems are designed well for low temperatures for a New England climate, um, which we believe indicates true system performance and shows kind of true operational costs. Um, the report takes each quote and also plots them on a line. And this is the second picture that we see on our screen here, right? So that's that impact on heating and cooling cost. Um, it plots the different quotes on a line and takes into account your geographical location because this matters, right? Um, Not only your geographical location, but also some of your home attributes, your home characteristics. And this makes a more customized efficiency rating and really models how these systems will perform in your home. It's a more in-depth look than what a spec sheet is going to be able to offer you or what a proposal is going to be able to offer you, right? The difficulty is on the surface, some systems may be rated on par with one another, right? There may not be a very visible difference in the actual function when you're just looking um, again, on paper at these systems and comparing them as they sit. But when we're looking at the weather in your area, we're looking at different design temperatures. We're looking at, again, using how your home is how tight your home is, how old your home is, your considerations, your motivations for adopting heat pumps. And we will, as kind of best possible as we can, um, model the actual conditions that the heat pump will be running in to create this more customized efficiency rating for your home specifically, right? So you'll see here, quote A is the one on the top, that it's on the left side of the kind of higher cost part of the graph. Um, So y- it helps you make the decision, or helps you look at the system as a whole, because we see that system A, or quote A, actually has the lowest upfront cost. Um, but over time, we actually might see system A costing a homeowner more, right? It might not either uh, work as well down to low temperatures. The efficiency might be a little less as it starts to drop in temperature and capacity. Um, and we're actually seeing kind of a similar thing for that other low cost option, which is quote C. It's a tiny bit to the left of that higher cost line, right? So again, it sometimes these quotes aren't as straightforward as this is the highest upfront cost and this is the lowest upfront cost. There are other considerations, because sometimes you can actually make back some of that upfront money that you're spending over the long term savings, right? And we see this kind of in quote B right there. Quote B is the highest upfront cost. It has the highest 5 degree or per ton at 5 degree cost over any of the models there. But we see that over as the actual operating costs are reflected, Quote B is actually going to be the most efficient option, or at least guide us to a lower operating cost over the longer term there. So it's again being able to figure out what your motivation is. Is it that long operating costs, considering that long operating costs and efficiency over a long period of time? Is it that upfront cost? It really just provides kind of valuable insights into these systems and how these systems will run. And then at the bottom, the last thing we'll highlight pretty quickly here is how efficient these systems are for heating and cooling. We break it down into both categories here, right? And we see something um, kind of on par with the operating cost changes, that quote B, at least for heating anyway, is going to be more in the higher range of COP, or coefficient of performance. And this is a value that indicates how efficient these systems are. So a lower COP is less efficient, a higher COP is more efficient. And we see here, right, the lower upfront systems of quote A and C are lower efficient. Again, not even anywhere close to approaching that, like, one factor of one. So 1 degree of energy in, or 1 degree of heating out. We're still above that line. Um, but quote B is a good deal more efficient and is approaching in that kind of green bars, and that's what we utilize to show kind of the desired efficiency. For the cooling costs, this is where, again, this, I think, tool is very powerful, is it goes in the heating realm, um, very different view than in the cooling realm, right? We'll see that it actually goes quote C, B, and then A. Um, and they're all actually pretty much in the same area, or at least similar areas. Um, and this is something that, again, residents don't have access to when we're just looking at a proposal on a piece of paper. These are the real time running data that is going to be important in the either long-term efficiency or long-term cost savings that you might be looking for in your adoption of a heat pump. So how do you gain access to this powerful and insightful tool? at no cost. I'll remind everybody, right? You can visit your Community First Partnership website. It's as simple as uploading up to 3 quotes, providing some basic home characteristic information like your year, square footage. Um, if you have a historical either electric or gas usage bill, that helps the program um, kind of spit out the best and most accurate information as possible. Um, and once you have provided all of that information, a heat pump specialist will run it through this software. We'll take a look at it and actually personalize the report. So not only are you getting this report run through um, and spit out kind of automatically, but you're also getting a human touch where they're looking at your motivations, your goals, comparing it to the systems and what the systems are showing on that report and giving you a little bit of targeted feedback. And if you have any questions either about the targeted feedback or the information reflected on that quote comparison report, you can follow up with your heat pump specialist and schedule a meeting. So you can talk one-on-one and really ask any questions that might be lingering, dive into any topics that maybe you're unfamiliar with, or even ask about like specific data points that might not be clear to you right off the bat, but with the help of a heat pump specialist, will kind of um, you'll be enlightened by, I guess. And after that, you'll be able to select the option that best meets your needs. And this is the aim of this entire interaction of the entire process is making sure that the equipment you are installing is the best solution for your home. And to incentivize this all, Mass Save, the sponsors of Mass Save, um, offer very generous rebates and incentives for adopting heat pumps, right? So if you go with that whole home solution where you are using heat pumps as that primary source of heating and cooling, you are eligible for $10,000 per home. If you qualify through, if you're an income qualified individual, that enhanced amount actually gets pushed up to $16,000. So there is a lot of money in play here that will help kind of add the initial investment in your heat pump. If you decide to go with a partial home system, maybe it's just for you want to use a heat pump and then have a traditional fossil fuel based system as a backup, or you want a switch over at a certain temperature, um, you have access to a partial home rebate, right? And that is going to be $1,250 per ton, coming back to that per ton figure, up to $10,000. So that is dependent on the size of the system you're installing, but still, um, a very generous, a lot of money that you are able to tap into and access to make this investment a little bit more manageable. And don't forget, we also have that 0% heat loan. Um, so the sponsors of Mass Save have given us a buffet of options that we can kind of choose from to again make this decision, which is a large financial decision, more manageable and make more sense to your kind of home, your bottom line, your wallet. We always like to just reiterate that there are efficiency requirements, that Mass Save does host a qualified product list. To be eligible for these rebates, you must use a heat pump off the qualified product list. There are thousands of configuration systems on that list, so you have wide array of options to work with there. Also, just to reiterate, to be eligible, you need to work with a 8-pin contractor, and all of this information can be found on masssave.com, so the MassSave website there. Lastly, there's just a few requirements. I'll keep this slide up just for a second. If you are going with a partial home system, you must install integrated controls. So this is what kind of coordinates your new heat pump system with your existing fossil fuel system. This just makes sure that they're switching over at a desired temperature, so that you are getting the best efficiency possible with your heat pump system, but also have that kind of reliable backup heat generated by a traditional fossil fuel system there. For whole home heat pumps, You must make sure that your home is sufficiently weatherized, and this can be done through that home energy assessment process. Um, and that needs to happen prior to the heat pump installation. And then once the sufficiently weatherized home has been achieved, once you have installed your heat pumps, you'll just have to submit a whole home heat pump verification form, and you will have access to those rebates, and you'll be able to claim the rebates within your within the boundaries of what you have installed, right? And there are a few more requirements. For more information, we really emphasize, please visit masssave.com. Everything there will be able to help you in this journey. Um, and that is it. We'll pause for questions, um, but you're ready to get started today. Through this Community First Partnership project, you have access to the no cost quote comparison report um, today. So if you already working through this process, if you already have quotes and are ready to make a decision, feel free to access this quote comparison report tool. Um, Feel free to reach out to us at cfp@abodem.com with any questions, and we will be happy to assist you in this journey. But thank you, everybody, for coming today, and good luck with your heat pump journey.